close till I get up. Time is barely on our side. I don't wanna waste what's left.
Assalamu alaikum and welcome guys to my another video. Actually this video is the second part of car parking slot identifier. Actually I found multiple requests regarding in my last video regarding to the diagram which was shown in the diagram at 152. So I've decided to make one video on that, but I'm late, sorry for that. Actually I left the YouTube, but now you will get my videos as on the daily routine, on the daily basis, as I'm publishing before. So before starting the video, it's a request to like. If you like the video, then like the video, press the like button, subscribe the channel, and don't forget to press the bell icon. So let's start the video. Actually in that diagram there was two silly mistakes which was now being solved by me. So those mistakes are: number one, the Y which was going in the second NAND gate, it was not from the button terminal. That was the first mistake. It was connected with the mouse button. And the second mistake was the motor connection was with the second end of the mouse button, not directly from the terminal. So before going more, let's discuss about the components of the diagram, which was, if you still don't watch the video of the car parking slot identifier, first I recommend you to go there and watch the full video and then come here, so you will get it properly. So here are the starting from the switch button which was there in the diagram, which we are using for the movement of the gate. Green button, actually it's a DPDT button, and means that double pole double throw button. The purpose of this button is it will throw the which we call then the current or the positive and negative on the both side. When you press on the one side, on the on side, it will throw positive negative, and on the right side it will throw as well positive and negative. Then here on the top comes up the motor which we are using to rotate for the motion of the gate. And here are the mouse button. Here these mouse buttons plays a very important role in the whole project, because on the basis of these switches the whole project is based, and they help for the gate, for the lights, to we can say that for the powering IRs, for the powering a gate, and for the powering of the these indication lights. And here on the last we have you can say you could connect any DC power. On the left side we actually placed the IRs on the left side, which was in the project was placed on the upper right hand side, the gates in which we are parking the cars. And here is the NPN transistor. NPN transistor is playing also very important role, because when we are getting the input from the IRs, those inputs are not too much powerful for to work as an input of the gate, but NPN helps to you can say amplify that power to help the gate to identify if any power is coming from the behind, and to turn the gate on and off. Then second hand gate is used. The purpose of second hand gate is to actually you can say that to operate the indication lights. Means that on the basis of the second NAND gate, all these lights are on the basis of or operate on the basis of only second NAND gate input. and actually second, the orange light is not having any link with the second AND gates. Only the red and the green light depend on the output of the NAND gate, second NAND gate, and the purpose of the NOT gate is to turn the green light on and off. And then going to discuss it in the with the help of some pass through. Okay, and one thing to be remembered here about the receivers, receiver which were connected right here. Actually, the receiver, you should remember the one thing, that the receiver should be in the connected in the opposite side, meaning that the positive terminal linked to the negative side of the upcoming current, and the negative side will be connected with the positive side, meaning that if the current is passing through this area, you have to connect the negative side of terminal with that current. Let's discuss it with the help of the flow of the current. Actually, one thing to be remembered here, that the DP and DT, double pole double through, has one property, that when you shift or to throw the current on the one position, it will throw it diagonally. Mean that these both are connected, are interlinked between each other with each other. Okay, now let's discuss the diagram. Actually, the role of the mouse buttons are that whenever the gate push one of the button, it will disconnect the flow of the electric current. Now see how it will be working in the project. Actually, as I told you, that there are the two mistakes, and the mistakes were that these cables are not the part of the project as shown in that diagram. It was connected as like this. So when the positive current flows from here, let's suppose to this terminal on the one side, and the gate is, as I told you, and the switch is interlinked with each other with terminal. So when the current flows here, the current passes here to the mouse button, and the mouse button will throw to here the positive current here. Now what happened, let's suppose the gate is on the closed position. In the closed position means that this switch button is now pressed. It means that it stops the flow of the current. The flow of the current is stopped here, so the positive which was going into the motor will not going, and now in the motor is not going to get the positive of the current. Now what about the negative side? Let's suppose negative connected here, and from this side the negative is going into the other switch, but that switch is now connected, and before this connection the negative is going into the one side of the motor. The motor is getting negative but not getting positive, because in the gate is closed and the switch button is pressed, and because the switch button is pressed, the current of the flow to the motor is disconnected, and because of that the NAND gate is getting the power 0, because negative is going from by the help of the first switch in the NAND gate is 0. Now see what will happening on the left hand side of the gate. Now we are talking about what will be the result of this thing. Now I'm not talking about the negative of the side. Negative is, you can say that it's a ground. Now that current is going into the first AND gate, because for the first AND gate we want one of the terminal we want the positive current, as you can say positive, or we can say a steady current, which should be 1. Now suppose there are no cars between them, so what will happen, that the transmitter throw their rays to the receiver. Receiver get those, actually receiver IR receiver work as a bridge between the current. Means that if it's connected with a wire, it will work like a bridge, and the current should have to follow the path from the IR to pass through it. And IR only works when when it received the IR rays. So when the transmitter, the receiver, the rays, the positive which was going into the transmitter, it will operate the transmitter, and transmitter throw the rays to the receivers. And what will happen, the receiver receive those waves and complete the flow of the current, and by joining the both current, it will input the NPN transistor. Now the input coming from the receiver are not much powerful to operate the NAND gate or any type of gate, so I'm using the NPN transistor here. What was the purpose actually was to place it here is that it will amplify the current. Means that it will, if it's getting the positive from here, from the negative or somewhere, it will amplify this current and throw 0 here, because it's the NPN transistor. It means that it's throwing 0 1 0, here negative on and off. So we are getting, as it's NPN, so here it will throw the negative throw. So if let's suppose we are getting now 0 here, what the purpose of NAND gate, what the NAND gate will do, because it at the one end is getting 0 and the second end it will getting 1. So what will happen, if it's 0 and 1 in the AND gate, it is 0, but it's a NAND not on the top, so it will convert it into 1, mean that now the NAND gate is outputting 1. So that output will be the input of the next NAND gate. Now what will happen, as I told you before, the second NAND gate is playing the role to operate the LEDs. So the operate LEDs, now it is getting 1 at the 1 in the 1 point and 0 at the second point terminal. And again in the AND gate, if you're getting 0 and 1, it's 0, but as it has the not on the top, so it's an AND gate, it will convert that 0 into 1, meaning that we start getting 1 as the output from the second AND gate. Now this input goes to this NOT gate. So when it passes from the from first NOT gate, it will convert it into 0, and that output will go directly into the green LED to help the green LED to be turned off and on. But as we are getting 0, so the green LED will be turned off, and as we get the 1 here, we connect this wire with the red light. What will happen, red light start blinking. So actually what was as told you, gate is closed, the power is off. Now what will happening here, as if we say that we park the car as well here, if we park the cars here, so we are getting this, if we let's suppose if we park the car here, we are not getting any input from here, as we suppose we are getting 0 from the second AND gate terminal. Now what will happen, 0 0 will be 0, and from the an easy word, let's suppose now the gate is closed. First condition, the gate is closed. Let's suppose the cars are parked in the let's suppose one of the car is parked in the car parking slot. Now what will happening here, the purpose of this input is to make the gate, to make the inner condition stable, mean that whatever will, when the gate is closed, whatever happening inside the parking will not affect the indication lights. Mean that if we're getting 0 here, if we get the 0 here, 0, so 0 and 0 will be 0 in the AND gate, but passing from the NOT it will be 1. So we are getting 1 here. The 1 will remain the red light to be steady. So the mainly purpose of this is to make the red LED stable. Whatever happening inside will not affect the indication lights. Now, and the second condition is in which now let's talk about the second condition. What will be happen in the second condition? Sorry for this disturbance, but let's suppose now the terminal when we press the button on the left hand side, what will happen when in the project is the gate is opening, and it will allow the inner circuit to be operate and to operate all these LEDs. Now what will happen? Let's suppose when the positive current flows here, it will go to the left side, and negative will also go on the right side, on the left side. Now what will happen? This positive current will go to the one end of the motor, and the same current goes here to the as the input of the orange light. And what will happen, as we can say that the negative of the orange light is grounded, or the negative fitted right here. What will happen when the button is pressed on another side, it throws that input to the orange light. So what will happen? Orange light starts blinking, or blinks, or you can say brighten. What about the negative side? What will happen in the negative side? From this terminal we are getting as a negative side, and negative current will flow here to operate the motor. Now what will happen right here? As I told you, they are interlinked between each other. So the positive flows from here to here from the switch. So when the gate is on this direction, mean it has to move backward. What will happen? As it's moving as far as as soon as it's going back in the direction to hit the back button, then the gate is now means that the button is switched on. The current is passing from that button, and when it goes back and hit that button, the flow of current will be stopped from here. So the motor will be stopped. And what will happen here, right here, that the so as the get what we call it, the NAND gate start getting the input. So as the NAND gate is getting the input from here, so it will getting now 1 here. As I told you in the previous diagram, we are getting 0 here. So 0 will allow all the condition inside to be steady and will not affect the whole project. But now when the second AND gate start getting 1, now it will change the whole structure of the project. Now what will happen? And on here, that input, the positive, goes here to as an input of the first AND gate. We want some input for the NAND gate, that's why we are getting now 1 here. We have to connect one of the input as positive in the AND gate. So what happened? The same setup will happen here, that current passes from the IR, and IR start current to transmitters, and transmitter, what will happen? The transmitter transmit their rays to the receivers. The receiver get those rays and change it into electric current, and then those electric currents are getting multiple here, and it's a condition when no car is placed there. Now this slot is also empty, this slot is also empty, car parking slot is also empty and empty. If empty, there is no space, so the rays are directly you can say transmitter directly throws rays on the receivers, and the multiple of those rays are going into the NPN transistor, and NPN doing the same thing, throwing 0 here. So throwing a 0 here. Negative means, and as I told you in the previous diagram, 0 here, we are getting 0 here. Now what will happen? 0 and 1 in the AND gate is 0. So in NAND gate we start getting 1, mean that we are getting 1 here. So 1 and 1 here as the input of the second AND gate. 1 1 is in the AND gate is 1, and from NOT it will be 0, mean that we are start getting as output 0. Now this 0 will go and switch off this red light. Now red light is off, the gate is open and red light is off, and when this goes in as the input of NOT gate, it converted into 1, and 1 will go and blink the green light, switch on the green light. The green light starts getting glow. Now what will happen now when the car parked there? Now suppose one of the cars comes and park in the one of the parking. Now what will happen? One car is parked, but the second is empty. Second slot is empty. We are getting the positive from there as the input of the NPN transistor. Then NPN still amplify this current and do the same thing as happening here, because the second gate in second parking is still getting the positive current. And it's no matter that one of the, if we block the one of the positive flow to the NPN. Let's suppose we block this one, it start getting positive from this parking slot. If we block this one, it start getting from this one. But will the change occur when the both will be blocked? When the both will be blocked, NPN transistor stop getting positive terminal, so it will not throw any output here. When all these sides are blocked, when all these parking slots are full and occupied by a car or of such vehicle, now NPN will not get any of the positive terminal, so it start getting 0, because of what? It will not throw any current here and the first terminal of the NAND gate. Now what will happen? Now here comes the work of that interconnection. Now what will happen? It has no NAND gate input. Now what will happen? It will start directly work as a NOT gate and convert 1 into 0. What will happen? We start getting 0 here, because 1 is there. From NOT we get 0, and when we get 0 here, what will happen? From 1 and 0 in the AND gate is 0, and when it passes from the NOT it will be 1, so we again start getting 1 here. Now what will happen? 1 goes here and blink the red light again. Now, and what will happen from the green light? The 1 passes from NOT, it will be 0, and 0 will go and switch off the green light. That's the whole diagram, and it's maybe I make it much complicated, but it was not like that. But if you compare it with the previous video or the project video, it will help you more and more. Thanks and best regards. Meet you in my next video. Allah.